Ideas, thoughts. So maybe the first question should have been, do humans affect the carbon cycle? The first answer to that, do they affect it? Absolutely they do. And how? What do they do? How do they mess it up or continue it or whatever? I shouldn't demonize them. So they put more carbon into the atmosphere. Is that because we're just full of a lot of hot air and we breathe out a lot more than most animals? No. Is it inherently because we are human that we put out all this carbon? What is it that we do that puts more? And I'm going to put quotes around that more because I want to talk about that more as first. But what do we do? Okay. So this more carbon, it's not that we're creating the carbon, right? And I want to make that really clear. We're not creating this carbon, but the more comes from inside the earth, she says. In what forms do we find it inside the earth? You've told me something already. Somebody else help me out. Where do we find it? Yeah. We find it as coal. Sure. What else? Diamonds. Now, I have a question. Do the diamonds give off the coal into the atmosphere? No, unless you burned them. I mean, that would be kind of right. Like you'd have to, there's a word for that. There's a word for that. Do you know what that, so we said coal. Let me write this down first. Coal, and what else did you say? You said diamonds, but then you said something else too, didn't you? Fossil fuels, yeah. Coal, fossil fuels, these things. The reason that carbon goes into the atmosphere is that what do we do with them? We burn them. We burn them. Yes, we do. There's another word for that, another more technical word. Starts with a C. Does anybody know what that is? Combustion. So burning and combustion. Combustion, it's just a fancier word. So, we're always trying to up your vocabulary game so you sound fancier and fancier. So this would be a new one, right? Instead of we burn the coal, right? Or we are burning the coal. No, the coal goes through combustion. That's like a good ACT word. So there you go. Okay. Is that carbon, I think we kind of said this, but is that carbon that we're making, or are we just finding? Finding. It's always been there, right? It's always been there. It used to be dinosaurs, and now it's the coal that we're using to burn. So that's important to know. Okay. Questions there? We good? Okay. That's actually, we're gonna kind of dig into this a little bit more, but I wanted to get our brains moving. Would you pull out your notes? The notes was that green sheet that you had yesterday. Some of you decided, I don't want to do a green sheet. I'm just going to write on my own paper. So if you're that person, then just get out that piece of paper. If you were doing notes from yesterday, they looked something like this. It was a green piece of paper. It said notes, carbon cycle. You probably wrote your name in period 1 at the top. So just some friendly reminders from what we talked about at the end of yesterday, because yesterday was a 24 hours ago, right? Carbon is an element required for life, and carbon is not static. It doesn't sit still. It moves around and around and around throughout all 4 spheres of the earth, right? This was an important one, and this is what I was trying to get at before too, because it's so important. If you have a highlighter, if you have a glitter pen, if you have glitter glue, or, sparkly stickers, this is one thing that I want you to put it by, because it's important. We said this at the very end of the day yesterday, and that is the amount of carbon on the earth is always the same. I can't remember if it was in this class or the other class. I think it was the other class that one of my students was like, we've sent things to space. So yes, the amount of carbon on earth is some tiny fraction of a fraction of a fraction of a percent less than it was originally, right? Because we sent a few things out into space. But there's a lot of carbon on the earth. And for all intents and purposes, it is completely the same, okay, the entire time. All right, we're going to flip that sheet over. We're going to talk about the other side. So there are 2 words on this other side. Do you know those words? What are they? Reservoirs and flows. Do you know what a reservoir is? I hope the answer is yes, but let's find out. What is a reservoir? Or where have you heard of that before? Yeah. Yeah, so Fossil Gorge, and there's that big, it is a reservoir. It's like a man-made lake. So when we talk about it in terms of geology, it's a man-made lake. So basically what they're doing is they're damming up a river so that it doesn't flood, right? So in that way, if we think about that, so you got the river that goes through Iowa City, and prior to us putting Coralville Lake in, which is actually a reservoir, prior to putting that in, the Iowa River would flood downtown Iowa City all the time. Okay, this was a long time ago that they put that in, but prior to that, it would just, and so instead we're backing it up so that, and that it makes a nice lake so we can go boating and fishing and blah, blah, blah. But it's like this extra big pool of water. Does that kind of make sense in terms of something that you may have seen or experienced? A reservoir, when we're talking about carbon, so let's write this down. Reservoir. A reservoir in terms of carbon, or in terms of a lot of other science terms, okay, is a place or a location where carbon is stored. Okay. So that kind of jives with the definition that we had for the Coralville Reservoir, in that it's where the water is stored, right? And then they let it out the spillway. So they let it out bit by bit so that it doesn't flood Iowa City. Same kind of deal. It's a location where, in this case, the carbon is stored. Another word that we sometimes hear for that is that it's a sink. So we would call it a carbon sink. It's a place where the carbon just goes and sits. Okay. Flows is kind of the opposite. And it is what it sounds like. Okay. It's the movement of carbon between reservoirs. Okay. So just a few examples. We can kind of think about, this is kind of similar to what we had said before. It's just using some different terminology. So can you think of anything based on the experience that we had the last few days of class that we've had of places that are reservoirs for carbon? Yeah. In the ground, absolutely. In the ground. So I'm going to use our spheres to talk about that. And so the ground would be in what part of which sphere? The geosphere, yeah. So the geosphere is absolutely a reservoir for carbon, right? That's where the humans find all that extra carbon, right? And there's just a lot of stuff that dies. And whenever anything dies and it sits on the ground, then it starts to decay. And that gives the carbon from, in that case, the living animals or the living things into the geosphere. Other reservoirs or sinks for carbon. Think about when we were doing our activity. Were there any other places where you got a lot of carbon? Yeah. Hydrosphere, for sure. Absolutely. In the water, right? We had a lot of carbon that got into the water and then kind of stayed there for a little while, maybe. Okay. Where else? Where else did you see a lot of carbon?
What was right there?
What's that?
Okay, what was right there, like the water?
Was that the water? Yeah, so that would be the hydrosphere. But yeah, they had tons of carbon, didn't they? It was kind of a little overwhelming. Yeah. Atmosphere. For sure. Yeah, that atmosphere has a lot. And especially once those humans got involved, right? Yeah, it was a place that stored a whole lot of carbon. That's a problem. We're going to talk a lot about that later. What about the biosphere? What do you guys think? Was the biosphere a reservoir? Did it hold on to carbon even for just a little while? Maybe. I mean, I kind of feel like in our examples, these ones hold on a little bit more. But if you think about it, a tree, right? Like a tree is standing there and it's getting a lot of carbon in from the atmosphere, right? And it's getting a lot of carbon in from the water and things like that. And it holds on to that carbon. I mean, the caterpillars are going to eat a little bit, right? All that sort of thing. But Who was a tree? I don't remember. Who were the trees? Elena, where could you give your carbon? The caterpillar, the sedimentary rock, and the atmosphere. So the caterpillar is eating like little bits, right? The atmosphere, you've got some respiration, so you're giving off some. But then a lot of it happens after you, right? After you tip over and you're done, right? And so that whole thing is really transferring a whole lot of carbon from the biosphere into the geosphere. So I'm going to say biosphere also could be considered a sink or a reservoir. We've kind of talked about this, but the more we say it, the easier it is going to be to remember. So the atmosphere, this is the flows part. Carbon flows from the atmosphere to the biosphere, right? Does so through, what was that? What was that process called? Atmosphere to biosphere? So the biosphere, that's the trees taking in the carbon. How do they do that? What's that process called? Starts with a P. Photosynthesis. Do you remember this? We defined it on the other side of your sheet. The biosphere for sure gives some off to the geosphere. During what processes? What happens? How does the biosphere give carbon to the geosphere? Yeah, that stuff decays, right? So living things. So I'm going to say living organisms die, and then they decay into sediment.
Wait, so you know how when people die, like humans die and they get hit to the ground, do they give off carbon to the geosphere, but do they not because they're in the...
That's a super timely question. I just read an article about this, actually. It's really kind of interesting. So it depends on the process through which a person is dealt with, I guess, once they've died. So like the traditional like embalming and then putting in a casket and then put into a big cement box, right? So in that case, not really. They're not really giving that carbon back off to the geosphere directly. It's kind of like encased in there, right? I did just read an article, and I don't want you to react badly to this because it's a new interesting thing about people who are choosing to donate all of their organs, which is like a great thing. You should all be organ donors. It's awesome. Yeah, so you donate your organs to other people or to, right, so people can learn. And then there's a process through which you basically are just buried such that your carbon and all the rest of your stuff literally just goes back into the earth. And it essentially, it sounds kind of weird, and I don't want anybody to take it in a bad way, but it's kind of interesting because then basically your body turns into compost and it makes the earth stronger. I was like, that's really, really interesting. And I'm not saying that you should do that, or I'm not trying to like, cause any like whatever. I just thought it was an interesting like new thing that some people choose to do. I think that's kind of cool. Anyway, sorry, I just had to like share that because I just like literally 2 days ago read that. So anyway, there you go. So biosphere to geosphere, but besides humans, I don't think any other organisms take any sort of measures to avoid their carbon going into the geosphere. Not that I'm aware of, or I haven't read that article. You can tell me if you disagree. All right. How about atmosphere to hydrosphere? Does the atmosphere give any carbon to the hydrosphere? Atmosphere friends. I don't remember who was in the atmosphere.
Yeah, I was. They were getting into the water.
They were, yeah. And how were they doing that? What were they doing?
Hey.
We weren't supposed to be throwing it, but the carbon dioxide was dissolving into the water, right? I do not have a skill for remembering random like trivia and numbers. It's really funny because I think a lot of times people partner up with somebody who's the opposite. My husband is like, he can tell you any fact anytime. I'm not that person. But I do know that it's something like 70% or 80% of all the carbon in the active carbon cycle is in the hydrosphere at any time. which is like a lot, right? I mean, that's a lot of carbon dioxide or carbon.
We have a lot of water too.
We do have a lot of water. Good call. So like, I mean, kind of percentages wise, but it's a lot. It's a lot. It's kind of amazing. All right. And then you could talk about the hydrosphere may give some carbon here. I mean, we could keep playing this game all day, mapping out all the things that we did, the last few days. I don't want to spend all kinds of time doing that. We can say that the hydrosphere gives some to the biosphere when, like the marine animals and plants absorb carbon in the water. Okay. Do you get the idea? Yeah.
You drink water? Are you like getting carbon?
Super good question. And I actually totally dropped the ball because I was going to do a little activity with you guys and I forgot. So if you're drinking like distilled water, then that is basically just hydrogen, oxygen, H2O, right? But how many of you ever have consumed pop? What makes pop fizzy, you guys? Carbonation, carbon dioxide. Literally, what do? My colleague, Mrs. Shamshore, brought in one of those, like the soda stream things, you know what I'm talking about? Where you like literally pump in carbon, and like literally all you're doing is taking the same stuff that's in the environment or the same stuff that we breathe out, that carbon dioxide, and they're just pumping it into the water. That's literally what it is. So absolutely, you consume carbon dioxide in that form all the time. Is it really great for you? I don't know. I mean, it helps me when I have tummy troubles, right? I have little bubbles in my tummy. I think that's a good thing, or maybe it's placebo. I'm not sure. But regardless, yes, we absolutely do consume carbon from water sometimes, okay? But again, that distilled water doesn't have a lot of it in there. There might be a little bit, but not a lot. Yeah, good question. Good question. Other questions about this stuff? Reservoir, you got it? Sink and flow, does that make sense? That's just the movement. That's really the whole point of this whole section, you guys. Carbon flows. It does. That's just a thing. All right. This right here is kind of a setup for the rest of the year. Okay? I am super excited that this is kind of like bringing us into what we're talking about, kind of moving forward for a lot of what we're going to do the rest of the year. Human involvement. We said this because we just did this in our capture question, but let's write it down so we've got it officially in our notes as well, that humans have changed the carbon cycle in terms of how quickly we introduce. Do you remember in that video we watched yesterday, they called it slow carbon and fast carbon? Do you remember that? Slow carbon is what I'm going to say here. Slow carbon. And we'll define that in just a second. Okay. Into the cycle. What was the slow carbon?
It's fossil.
It's the fossil fuels. And what did you say, Libby?
It's like old.
Yeah, it's really old carbon. So it's essentially from dead plants and animals under heat and pressure for thousands of years. It takes a really, really long time to make coal. Okay, it's not something that we can just have a factory. Okay, we're going to make some coals and we can burn it, right? If that was the case, then that would be great, because then we would be able to harness that and then we could use it, and then that cycle would be really fast. But the carbon that we use from the fossil fuels is really, really old, and it takes thousands and thousands of years, millennia, for that carbon to be created in the right form so that we could use it, right? Conversely, let's just compare real quick. What is fast carbon? Can you give me an example of fast carbon? Banana, that's what they used in the thing, right? Yeah. So like it's basically all of the carbon that's moving around. When we did our experiment the first time, before we got the humans involved, all of that process was happening really, really fast, right? It was like things just went over and went over. And I like that in the video they said that, I can't remember exactly what they said, but it was something like the carbon in the banana, it absorbed, 2 days ago. And then you consume it. So it's going from the atmosphere to the banana to you in like maybe a week, right? And then you eat it and then you expel that carbon in like an hour, right? So that's fast. That's a fast cycle. Then it goes right back to the atmosphere. That's a cycle right there. You with me there? Okay. This stuff takes forever. Okay. Fast carbon, that's just the quick, I'm going to call it the regular carbon cycle. So in my little master notes, we drew a cute little picture. So I'm going to go ahead and draw that picture for you. Okay. So we've got, I need some black. So we got these coal reserves. Okay. I mean, yeah, we have like two more lines that we need to write below it. So I see that I'm kind of like taking up all the time. So if you could maybe leave yourself just a little bit of space. But yeah, we're going to take the coal reserves and we're going to send them to a power plant. That's usually where our coal goes, you guys. And in a power plant, if you've ever driven by a power plant, it has a smokestack. And what's coming out of that? Smoke. It's called a smokestack for a reason, right? And so that's sending all of that carbon up into the atmosphere. And I don't know if you remember yesterday when we were doing this, and the people in the atmosphere were getting, tons more coal, right? And so it was like, oh my gosh, I have to deal with that. Now, we got a little bit silly when we were doing it and maybe took a few at a time or started chucking them across the room as opposed to walking them across. I'm giving you this carbon, blah, 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 right? And doing it like we were doing before. I want you to imagine, if you had been playing by the original rules and the humans kept bringing carbon over there, what's going to happen to the amount of carbon that's in the atmosphere? It's what? It's just going to keep getting bigger and bigger, right? Yeah, it's going to be too much eventually. So it goes up to that atmosphere. And the atmosphere then, as Haley says, has too much carbon. And carbon dioxide, for better or worse, is really, really good at holding on to heat. Okay, it's really, really good at it. That carbon dioxide holds on to that heat and doesn't allow it to pass through like our atmosphere normally does. I mean, we want it to hold on to some of it, not a lot of it. It holds too much of it. And then what happens to our atmosphere then, friends? Do you know? What happens to our Earth? What's that? Becomes hot. Have you heard about that before? Yeah, that's where it all comes from. It's all really from this. That's it. That's it right there. Okay? So coal reserves, the fossil fuels. And the other word I wanted you to write down was combustion. Yeah. This is the all too real result. I heard a story on the radio yesterday when I was coming home that, they talk about climate change a lot. They talk about global warming a lot. There's a guy who works in the Himalayan mountains. Do you guys know where that is? Okay, so if you imagine a map, India's here, China's here, and right in between, that's where the Himalayan mountains are, the tallest mountain range in the world. Okay, and there are a lot of glaciers in those mountains, right? Which makes sense. Those glaciers are melting faster than they've ever melted. And the scientists have said that, they always say, we got to get this done. We got to get this done. They've mapped it out. They said within 8 years, we will reach the point of no return. So before you graduate from college, if we haven't fixed this problem, we're screwed. I mean, it's not going to be like an instantaneous, but like that's fast. Eight, right? How old are you right now? You're like, it's like twice you're like half of your age. You see what I'm saying? Like it's not very much time. It's kind of like, holy cow, we got to get our act together, friends. We got to get our act together. That carbon holds on to heat. It's not fine. It's not even probably fine. Yeah, until you turn into a little like raisin of no, it's gonna be bad. Holds on to heat, okay? By that I mean the sun's energy. And it warms the planet. Over time. Wah, wah. Sorry to be such a Debbie Downer today. It's going to be a rough few months for us. So that's okay. We got this. We can handle it. All right.
It'll be a rough 8 years.
It is. And after that, it's going to be even worse. Okay. Questions on this? What's that?
Like what you saw and stuff.
There you go. There you go. At least there's a little hope for at least next year. All right. We have a couple of things to work on. Oh, I threw the other thing in there, but I can't find it now. So, yesterday I gave you, or maybe it wasn't yesterday. Was it just yesterday that I gave you the sheet? Does anybody need one of these? You guys all have it. Okay. We've got this. I've also got a review game that we can play. We've got about 25 minutes. So I want to give you a little bit of time to look over this. And then I will collect some people that would like to do a review game up here. Does that sound good? Okay. So I'll give you, 5 minutes or so to look over this. If you have questions, I'm super happy to answer them. But I want everybody to have this gold piece of paper out. Okay. And be engaging with it, not with somebody else about a basketball game or something like that. Okay. Thanks. Yes, you may.